Okay, so we've done simple interest and we've done compound interest, and we discussed previously that the key idea for compound interest is that the principal amount changes. Okay, so after whatever the time period is, your new amount is the amount that you're working with. And then simple interest is always based on the principal or original amount. Okay, so you should write that down. And that's the prerequisite knowledge that you should have read through. And we're going to highlight some important information here. So Eleni wants to borrow money for 3 years, so 3 years is important. And then pay all the money back with interest. Okay, with interest is important. The bank will not allow her to final debt, including interest, to exceed 30,000. Okay, and interest is 9% per annum, which is per year. And then again, this is important, isn't it? It's compounded. It tells us it's compound interest, not simple interest. So each year, Eleni will need to pay how much? Okay, how much percent of the original amount borrowed? Okay, so each year she has to pay 9% per annum. So that means whatever she borrowed, call it A, say, will be increased by 9%. And an increase of 9% corresponds to multiplying by 1.09. Okay? If you add 9%, it's the same as timesing by 1.09. If you don't believe me, you should try both. Okay, so to pay 109% of the original amount. This corresponds to multiplying by 1.09. And we can complete the diagram. So I called my original amount A, and then after 1 year, this is how much she needs to pay back. And after 2 years, because it's compound interest, it's based on this amount, this new amount. And it's this new amount, again, increased by 9%. So we have this new amount times 1.09. Okay, and we know that 1.09 times 1.09 is 1.09 squared. Okay, squared. And then this is the new amount when it's been increased at year 3. So we times this new amount, the A times 1.09 squared, by 1.09, and we get 1.09 cubed. So the final debt can't exceed this, so the maximum value is this, and the final debt is going to be this. So they're the same thing. Alright, write an equation that relates the original amount A and the final debt of 300,000 by completing the following. With the original amount A, which is here, yeah, we started with A, so we're just writing an equation in terms of A, that's what we want to do. The final debt is the original debt times 1.09 squared, that should be there, and we called our original amount A. So that's my A. Sorry, formatting's being a bit funny. A. Okay, don't worry about the color coding. 300,000 is my original A times by, it was a cube, sorry guys, times by 1.09 cubed, okay? So this is a number, and then this is a number, 1.09 cubed. Now, we should be able to work with these kinds of equations. And in the prerequisite knowledge, I talked about multiplication facts, you know. So if 4 equals 2 times a number, then 4 divided by 2 equals that number. Now in algebra, what we do, if we don't want to think about it like that, we say, okay, I've got two groups of x here. I'm going to draw a picture. I've got two groups of x, that's x, that's x, and this is 4, and it's balanced. Okay, they equal the same thing. Think of it as weights. Now, how am I going to find out what 1x is? Well, I can kind of see by this picture that x is 2, but I can halve the amount I have on the right hand side and halve the amount I have on the left hand side. And that corresponds to dividing by 2 both sides. Divide by 2 both sides. And we get 2 is 2x. Okay, so in this equation we have 300,000 is A times a number. So what I'm going to do to both sides to find out what A, my original amount, is, well, I need to divide by 1.09 cubed, both sides. 1.09. And I get A equals 300,000 divided by 1.09 cubed. Okay, and you plug that into your calculator. Let's do that. Just waiting for my calculator to load. Depreciation is sort of, you could think of it as negative compound interest. Okay, depreciating, you kind of think decrease with the D, and it's going down in value every year. So it's negative compound interest, that's the key idea. And then how do we reduce amount by 10%? Well, you would multiply it by 0.9. Find 90% of that original amount. If you're reducing by 20%, you'd have 80% of the original, so you'd times by 0.8, etc., etc. Let's see if we can use our CAS. So I had, oops, that was small. Sorry, it's not the best screen size.